All right, so what we end up having is we have ourselves our ideal gas law. Once again, not a big fan of writing it this way. I'm a big fan of writing it PV over NT is equal to R. Now, what does this actually mean? What is R? How does R work? Well, imagine if I take myself 1 atmosphere of pressure. So this is 1 atmosphere pushing down of pressure. And I'm gonna put it 1 mole of gas inside of there. So I got 1 mole of squeezy, 1 mole of stuff. And I'm gonna hold it at 273 Kelvin. 273 Kelvin, 0 degrees Celsius, 273 Kelvin. We use Kelvin. Kelvin is the absolute scale, absolute based on 0. And the reason why we want to have an absolute scale that's based on absolute 0, the coldest you possibly can get, is because of the fact of we don't have negative numbers. If we have negative numbers, we might get some silly things up here like negative volume. Tell me what negative space looks like, or a negative mole. You can't have a negative amount of stuff. So what ends up happening is this is the amount of movement. It's called standard temperature and pressure. 1 atmosphere, 273, standard temperature and pressure. Not really a big deal. Standard is just meant as in this is what we're using it as, is a standard to kind of base measurements on. 1 mole. What it does do with 1 atmosphere of squeezy, 1 mole of stuff moving around at 273, it takes up 22.4 liters of space. That's just what it does. So you hear 1 mole at STP takes up 22.4 liters of space. It's just because it does. It just takes up that amount of space. Now, we do the math here and we get 0.08216. And the units are atmosphere, liters, moles, Kelvin. This is R. This is a number that is emblematical of that relationship between pressure, volume, moles, and temperature. This is a number that's representation. You know me, I love that stuff. I love representational numbers. This is a number that's representational of this relationship. Now, what we can do now is we can see that PV over NT is equal to R, and R is always gonna be that number. It's called the universal gas constant. Now we can rearrange this formula. I still don't like rearranging it. I hate that we rearrange it, but we can rearrange that formula, and now we have ourselves our PIV-NERD. We have our ideal gas law. And all that means is that we have this ability, and if I take these guys back to the way I like it, if I plug in P, and if I plug in V, and I plug in T, and I know R has to be maintained, I can calculate how many moles we have. So basically, this is using PIV-NERD, using this ideal gas law. What we end up having is just, if I know 4 of the 5 variables, I can solve for the 5th. That's all that is.